Welcome everyone to another session on current affairs by S3CCI Academy. In this session, we will be discussing about a major volcano which actually erupted in Ethiopia. So the name of the volcano is actually Hayli Gubbi, and it was in news because the sulfur dioxide that was actually emitted by this volcano actually formed a gas cloud, a plume. Kind of like when atom bombs explode, you see a mushroom plume, right? Similar to that, a large plume of sulfur dioxide was actually created, and it actually was slowly moving towards India, right? So that was the news, and it said that by around a few days after that, it will slowly move over, it will pass over to China. So in this session, we will be discussing about why that particular volcano erupted, then what kind of volcano it was, and we will look at various specific formations, extrusive formations also associated with volcanoes, right? Okay, so this was the news. The Hayli Gubbi volcano in northeastern Ethiopia actually erupted. It was for the first time in about 12,000 years, right? 12,000 years. And a high altitude cloud of volcanic ash, a plume which we call it, which actually from Ethiopia it entered into India, and it will cross over to China by next Tuesday. Okay, so this is just an image, a satellite image by the Copernicus satellite. You can see the sulfur dioxide plume cloud that was actually emitted, and here you can see the Hayli Gubbi volcano, right? Right. So you can see Ethiopia here, and also remember Ethiopia is a landlocked country. Remember that Ethiopia is a landlocked country. Okay. So this is essentially the layout, or this is the important part that you need to know, because if you look at the plates, right, here you can see a lot of minor plates here. You can see the Arabian plate, you can see the African Somalian plate, and the African Nubian plate. So we know that whenever there is plate boundaries, or most of the volcanoes, earthquakes, all these things happen at the plate boundaries due to the plate interactions, right? So if you are familiar with the normal fault, so here you have one plate. Okay, this is actually the plate boundary, right? Okay, this is the plate boundary, and then you have these plates. Please imagine them as horizontal pieces, right? So if they move away from each other, it actually triggers a normal fault, right? Normal fault. And what happens after a normal fault happens? It actually happens if you go into little detail. It's due to divergent convectional current in the mantle, right? The divergent currents in the mantle. So we are not going to deeper into that, but just know that these kind of structures will be formed, right? This is known as graben, right? So what happens? This is known as the horst, right? What happens? The two plates actually moves away from each other, right? They will be moved, and the other plate will subside, right? And the subsided portion is known as graben, and the uplifted portion uplifted part is known as horst. So when these plates actually separate, you have the divergent currents here, right? The divergent mantle currents, right? So the magma actually seeps outside, and that's how a volcano happens in these plate boundary regions. So remember, the Arabian plate, the Nubian plate, and the Somalian plate are actually moving away from each other. That is why it's called the Afar triple junction, right? It's a triple junction of three plates, and they are moving away from each other, and it creates a volcano. The magma will come into the surface, right? And another important point is that so there is a region, Afar region is here, right? And this is known as the East African Rift Valley. Okay, the East African Rift Valley is also created because of this plate interaction. Okay, so this is more in detail about the volcano. It's actually the Hayli Gubbi volcano. So here you can see the southernmost volcano of the Erta range. That's an important range, it's in Ethiopia, and the southernmost volcano is actually this volcano, Hayli Gubbi. So whenever you study a particular volcano, you need to know whether it is a composite volcano, which is a stratovolcano, or a shield type of volcano. A stratovolcano will have what you can say, more viscous lava, right? And the lava layers, when they come onto the surface, it will be deposited very close to the fissure, and it will just deposit over each other, and it will create a cone, right? Conical fissures will be created in a stratovolcano. But in a shield type of volcano, the lava is less viscous. It flows more easily, and it spreads out over a large area, creating a like a large, wider cone-like surface, right? So this is the surface through which the magma will actually come outside. It will be a shield volcano. This is a shield volcano, and this is a stratovolcano. So I hope these two types of volcanoes are clear. And Hayli Gubbi is actually a shield volcano. Okay, it's basically because of the lava is less viscous, right? And it's less viscous because it has less silica content, right? The silica content is less. Silica content is less in shield volcanoes, right? So it makes them easy to flow, and it will spread over a large area, and it is also known as basaltic volcanoes. Basaltic, okay, or basic lava. Okay, it actually erupts. Okay, it actually erupts basic lava, right? And it is also known as a basaltic volcano, right? So it's not like an explosion, right? It's not an explosive type of lava. It just slowly seeps out. Not that slowly, but still it just flows. It flows more in a gradual manner. Okay, so here you can see that there is a graben is there. So you can see, I just mentioned how a graben is formed, right? When the normal fault happens, place will sit. A scoria. Scoria is actually what you can say, a particular type of rock which is dark colored, and in which this gas actually gets liquefied inside, right? Pumice stones are different. Pumice stones are more light colored. Scoria is actually quite dark colored stones in which the gases had actually liquefied. Okay, actually due to the intense heat, the gas tried to escape, but it got liquefied when the rock got suddenly cooled in the surface. So that is a scoria. Then you can see a fissure system is a fissure. So essentially, in a shield volcano, what happens is that you have a cinder cone is there, right? A cinder, these kind of cones will be there, right? And this is a linear system. Okay, it's a linear system through which the magma actually seeps out, right? Not magma, lava actually seeps out, right? Then okay, so this is more in detail. The shield volcano, basic lava, it's non-viscous, basaltic, low silica content. Okay, there's a fissure vent. Okay, so essentially how the lava actually comes out through fissure vents, which are actually linear vent, right? It's not like going straight upwards and just exploding out, but it's a linear vent, right? It's a linear vent along a line. It happens. Right. Then you have what is known as the cinder cone. Okay. Remember this terminology associated with the volcano. Cinder cones are made of loose pyroclastic fragments. Pyroclastic fragments refers to all these ash, cinder and all those things that actually comes out of a volcano, right? So a general name for those things. So loose pyroclastic fragments that actually builds on top of each other is known as a cinder cone. Remember? Loose. Okay, so it does not have that much of strength. It is composed of loose material, right? And then you have a crater. Remember, when you remember a crater, remember that it's an inverted cone, right? Inverted cone-shaped vent, okay, and through which the magma actually flows out. Then scoria. Scoria is a dark colored vesicular volcanic rock that is formed when molten lava cools, solidifies with gas bubbles trapped inside. I just explained it. Okay, remember it is dark colored. Okay, pumice stones are light colored. Okay, then you have spatter cones. Spatter cones, like, so this is the volcano, and magma is there, and it actually emits outside, and so here all you have vents, right? You have linear vents all in these sides. So a particular type of chunk of say molten lava actually got emitted, and it got it deposited in the along the edge of along the slope of the the volcano. But since it is still hot, it actually changes its shape. It actually spatters, okay, or what is known as agglutinate. It agglutinates, and it is kind of like becoming another, okay, it's kind of like another shield volcano will be formed, right? Okay, so a spatter cone occurs when a piece of lava or molten lava, when its explosion happens, it deposits it on the side, and it actually what's the word, spatter, it spatters onto the fissure, right? It spatters onto the ground, onto the fissure, and it also acts as another volcano, right? A small volcano, right? Then you have pit craters. Pit craters happens when kind of like a crater lake only, okay, a depression formed by the sinking or collapse of the surface. So when the surface actually collapses, there is nothing underneath, because all the magma actually got emitted, erupted. So when the surface also collapses, it creates a pit crater. Okay, so just remember a few terms like this. So whenever you study a volcano, please study the extrusive and intrusive formations. These are all extrusive formations. Okay, intrusive formations, sill, dike, baccolith, lapolith. Okay, just remember the picture, remember the type of structure as well. But this is about the Hayli Gubbi volcano, which was a shield volcano, and these are some of the extrusive formations associated with the shield volcano. Okay. Okay, so this is a question for you to try out. Consider the following statements regarding the Hayli Gubbi volcano. Hayli Gubbi is a volcanic complex located in the Ethiopia's Afar region. Okay, Afar region. It is primarily composed of basaltic lava, typical of shield volcanoes. So if you know that Hayli Gubbi is a shield volcano, this is easily solvable. The volcano lies along a major triple junction where three tectonic plates diverge. Okay, please read it carefully. It could be given converge, right? Okay, these are the areas where UPSC actually tricks you, because you may remember it's a triple junction, right? So immediately when you read it, you may just latch on to that point, but read it completely. Here it says diverge, but read the question completely in your real exam. So this is actually correct, and this is also correct. Right, so you will reach option D, which is all three, 1, 2 and 3 are correct. So that's all in this session on current affairs on Hayli Gubbi volcano. Thank you.